Okay, so this video we're going to be looking at some different transformations of the exponential functions. Now, the different exponential functions our exponential functions all go under the same transformations that the non-exponential functions go under. So, you know, if you multiply it by something, then it just increases the magnitude. If you change the x to negative x, and it reflects it in the x-axis. If you change the y to negative y, it reflects it in the y-axis, and so on and so forth. So what we're going to do is we're going to have a look at some key parts of the exponential and some of its transformations. So what we're going to look at first is we'll have a look at g of x is equal to, and what I'm going to do is we're going to hide this one, and we're going to put in I'll change the color so we can tell the difference. And we're going to look at this one first. So g of x is equal to 2e to the x. Okay. So 2e to the x. So essentially for this one, we're multiplying everything by 2. Okay. So that is the 1 will multiply to 2. Okay. This value here will double up. And so essentially what's going to happen is all these values are going to double. Okay. Including these ones too. So this point here at -1, so 0.368 will double up to 0.7, etc., etc. And there we go. So we can see that one there. So this one has got the double there. There's a double there too. And as we go up, the jump between it gets bigger and bigger and bigger. Okay, so that's a pretty straightforward one. Okay, the second one we're going to have a look at is, okay, e to the x plus 1. Now, this one's pretty straightforward, basically saying take this function here, and what we're going to do is we're going to add 1 to it. And you'll see it's exactly what happens. Okay, so it doesn't quite look like the same shape, but if I was to move that one back down, so if I got rid of that one there, it does go straight back on. So it just moves every single point up exactly 1. So as you can see, the gaps are all going to be the same. It just looks like it gets smaller and smaller as you go further and further up, but the gaps are still the same. The gap is still 1. It's just that the horizontal gap gets smaller and smaller as it increases. Now, for this one, you can see that we have an asymptote for the exponential function at 1. And the original exponential function, we had an asymptote at 0. So basically, it just kept getting closer and closer and closer to 0, but it would never actually touch it. So when you add or subtract values, so if I was to subtract 1, so moving it down 1 instead, okay, the asymptote also moves, or also gets shifted in that same amount as well. So if I move it up 1, then the whole asymptote and all of the function gets moved up 1. And if I shift it 1 down, or 2 down, or 5 down, or however far I shift it down, okay, that function or that asymptote also follows as well. So you can see that asymptote follows there too. Okay, the next function we want to have a look at is minus e to the x. So minus e to the x, so this one. So essentially what it's saying is take the original function and we're effectively just going to be flipping it in one of the axes. So this is the same as having e of x is equal to, negative y is equal to e of x. So if we're changing the negative y to negative y, then that should be a reflection in the x, okay? So as you can see, all the values have been reflected along that x value. And in fact, you can even say that technically the asymptote has also been reflected on the x-axis too. It's just that if it gets reflected on the x-axis, it's going to end up on the x-axis too. But see, we've got the -1 to 1. We've got this point here, which is the -1, 0.368. This one should be -368, and so on and so forth. So that's just a regular flip that way. Okay, the fourth one that we're going to have a look at is minus x. So minus x in this case, we're replacing the x, okay, the x value. So this is going to be a reflection, but it's going to be a reflection in the y. And what happens with this one is that we notice that it's going to be the exact same, but it's just essentially been rotated 180 degrees in the y, or it's been reflected in that y-intercept. So as you can see, we've got the 1s still at the same spot because they're still being reflected there, but the 1 value and the -1 value are still the same. The 2 value up here is the same as the 2 value up here. Kind of almost looks like a parabola, but not quite. Almost a parabola, but not quite. In fact, these exponential functions grow quicker than parabolas. So if I put a parabola next to this one, so y is equal to x squared plus 1. So it looks like, you can see here that these ones actually grow quicker than the other one. And why do they give me the same colors? That's annoying. So we'll go green for that one. So as you can see, the green parabola, okay, the blue actually grows quicker. So it looks like, the green one's falling away, but that's just because the blue one is growing quicker. And on this side, it's the same thing. The red one's going quicker too. Quicker, not quicker. So we can get rid of that one. And the last function we want to have a look at is when we do both. So as you recall, if we replace both of them, then it's going to be reflection in the y and the x, or the x and the y, which is the same as reflecting it along the line y is equal to x. So we should end up with a curve that goes something like this. So I click that one, and there we go. There's our curve that gets reflected there. Okay, so here's my line. Okay, and so this distance here should be similar to this distance here. Oh, not quite actually. But either way, it still had that reflection in the x and that reflection in the y. So if I do it step by step, so that's reflecting it that way, and then the next one will just flip it down. So you can see how it flips down there. So this one flips it that way, as you can see. Whoops. And then the other one flips it down. Or you can do the down way first, and then you can flip it that way too. So that's basically the transformations of the exponential function. So as I said, they're pretty much exactly the same as the other ones too. What you can do though, just to double check, is just to do a quick table of values to verify that your values are what they are. Now when we do table of values for exponential functions, we typically prefer to use values of e, and then we can use our calculator to evaluate those values of e. So that being said, that's going to be the end of this video. It's going to be the end of the introduction to exponential functions, base E, and transformations. I'll see you guys in the next series of videos.